All right, good afternoon. We're going to finish up section 1, 8.1, by looking at one more theorem, some numerical problems, and then we'll just change gears a little bit at the end. First, the theorem, it's called the polygon exterior angles theorem, and it just simply goes like this. The sum of the exterior angles of a convex polygon is 360 degrees. And what I'd like you to do is, in parentheses at the end of that, right, at the end of that, just write the phrase does not depend on the number of sides. Before our long weekend, when we were talking about interior angles of a polygon, it did matter how many sides the polygon had. It mattered if there was 4 or 5 or 6 or 7 or 8 or 9 or 10. It mattered. But with the exterior angles, it does not. So the sum of the exterior angles of a convex polygon is 360. It doesn't matter if it has 3 sides, 4 sides, 5, 6, 7, 8, 9, 10, 12 sides, 100 sides. The exterior angles always add up to 360. Okay? So the idea, if we were to have a triangle as an example, and we created the exterior angles. Remember, we do that by taking one of the sides and going past a vertex, but we can do it multiple times. We could do it again on the next side, and we could do it again on the next side. So what we form is, in this case, 3 exterior angles, so 1, 2, and 3. And what this theorem says is that the sum of those 3 angles, I'll just call them 1, 2, and 3 to be boring. So the measure of angle 1 plus 2 plus 3 always adds up to 360. Okay? And again, doesn't matter if we have 3 sides or 4 sides, just doesn't matter. Here's a quadrilateral. If we create the exterior sides by going past the vertex, past the vertex, past the vertex, past the vertex, all the way around, we create again all of these exterior angles, 1, 2, 3, and this time 4. And what the theorem says is that all 4 of those exterior angles then, 1 plus 2 plus 3 plus 4, will always add up to 360 degrees. All right? So 3 sides, 4 sides, 5, 6, 7, 10, 20, always adds up to 360 degrees. Okay? So get that theorem down. The sum of the exterior angles of a convex polygon is 360 degrees. Okay? And again, it does not depend on the number of sides. All right? And then what we're going to do is transition into some numerical problems. So I'm just pausing to make sure everyone can get that down. And then we'll transition to some numerical problems. And I've got 3 or 4 that I can do for you guys. And for yourselves, it's probably a good idea to get 2 or 3, 2 for sure, 2 or 3 into your notebooks. Okay? So you have something to look at and reference. Okay, so here come the numerical examples then. Our first one is going to be starting off with a 1, 2, 3, 4, 5, 6-sided polygon, so hexagon. And it's going to look something like this. So that's our 6-sided hexagon. And what I'm going to do then is create exterior angles by extending sides past their vertex. And I'm just going to continue to do that all the way around. So we've created 6 exterior angles. Now I'm going to give you the measures of some, like 93 degrees, 46 degrees, 3x, 62, 4x, and 47. And what I'm going to ask you to do now, create a numerical problem. I'm going to ask you to find the value for x. All right, so at the end, what I want you to be able to do is tell me the value for x. Okay? So again, the theorem that we just looked at says the sum of the exterior angles is always 360. So the idea is to start with any angle you want. Just for the heck of it, I'll start with the 93 and work yourself around. So what this means then is 93 plus 46 plus 3x plus 62 plus 4x plus 47 has to be equal to 360 degrees. So what we do is we create an equation by just going around, going all the way around the polygon and adding up all of the angles. And again, it doesn't matter how many sides this thing has, the exterior angles always add up to 360. And so what's left then is to solve the equation. So combine any terms that have an x, so 3x's plus 4x's is 7x, and then use your calculator to combine all of the plain old angles, so the 93, the 46, the 62, and the 47. Use your calculator to put all of those together. So give me a second. 93 plus 46 plus 62 plus 47 is 248. Then move plus 248 to the other side by subtraction. So 360 minus 248 is 112. And then to get rid of times 7, divide by 7. So when we divide both sides by 7 then, the value for x, which is what we're searching for, is 16. Okay? So even though the problems might look pretty complicated, they're not going to be too bad. They're not going to be too terribly bad. Okay? So just going to pause so that anyone who needs to can finish that one up. So we create an equation by adding up all the exterior angles. They'll always add up to 360. We put any terms together with x, with the variable, combine all of the other angles that are just plain old numbers, and then just solve a fairly simple equation. Okay? If you need more time, Miss Olson could maybe pause the video. Just let her know. Maybe she could pause this if you need a little more time looking at any of these problems, any of these examples. Okay, here's another one. Again, I'll try to draw out the picture first. So there's a 5-sided polygon, pentagon. And again, what I'm going to do is create the exterior angles by sending out the sides past the vertices. And I'm just going to, again, do that like we always do, all the way around the polygon. So we're going to create 5 exterior angles. Okay? And again, what we'll do then is look at the exterior angles. This one's going to be 80 degrees. This one's going to be 70 degrees. This one is going to be 4x degrees. This one is going to be 2x, and this will be a single x. Okay? And so what we want to do again is find the value for x that makes this true. And to accomplish that, we just begin at one of the angles. Just for the heck of it, I'm going to start with that one right there. And I'm just going to work myself around. So the first angle, x. The second angle, 80. The third angle, 70, the fourth angle, 4x, and the fifth angle, 2x. And the theorem says that they once again add up to, always add up to, no matter how many sides you have, 360. Solve the equation by combining all of the terms with x's. 1x plus 4x plus 2x, 1 plus 4 plus 2 is 7x. Then put together any numbers that are just plain old numbers. So 80 and 70, just put those two folks together. 80 plus 70 is 150. Then move plus 150 to the other side by subtraction. And get rid of times 7 by division. So 210 divided by 7 then would give me an x value of 30. And if we needed to, we could go back in to any angle that has an x and replace the x with 30. So 2 times 30 would make this angle 60, 4 times 30 would make this angle 120, and so on. So if needed, we could always go back and find the actual measure for any of the angles. Okay? All right, again, ask Miss Olson to pause the video if that would help out, if you need a little bit more time on any of these. Okay? Here's another example. Again, just going to start with the picture. So here, little short side, on side, and coming back to where I started. Okay, so this one has 1, 2, 3, 4, 5, 6, 7 sides, and I'm going to create the exterior angles by extending sides past vertices. All right, so just going to do that all the way around. Okay, and then I'm going to give you information about the angles. So 8x, 1x, 54, oops, can't read that, 45. Let's see, this fella right here was 54, 45. This one was 50. This one was going to be 42. That's kind of out of scale. Sorry, that one got out of scale a little bit. And then that one's 4x. So my picture went a little kitty-wampus there. But you'll get the idea. The scale doesn't have to be perfect to be able to solve one of these. So again, we just start with one of the angles. Doesn't matter which one. Just for the heck of it, I'll start with that one right there. And we just add up all of the exterior angles. So I'm going to start with the single x, then add up 54, 45, 50, 42, 4x, and 8x. And again, when I add up all of the exterior angles, the sum will be 360. So x plus 54 plus 45 plus 50 plus 42 plus 4x plus 8x. And then we have to solve the equation. So like we always do, combine any terms that have an x, so there's 3 of them, 1x, 4x, 8x. 1 and 4 is 5. 5 and 8 is 13. Then combine any numbers that are just all by themselves, in other words, no variables attached. So we could put all 4 of those folks together, 54 plus 45 plus 50 plus 42. So I'll add those up, giving us a total of 191. And then what we'll do is move plus 191 to the other side by subtraction. So 360 minus 191 is 169. And then to get rid of times 13, we divide by 13. And so 169 divided by 13 is 13. And we have our missing value. Okay? So hopefully you're starting to get the hang of it. I've got one more that I'm going to jog through. Again, feel free to put 2 or 3 of these down into your notebooks. All right, so one last one, and then we're going to change gears and go to something a little bit different. Okay? All right, so one last picture here. All right, and again, creating the exterior angles by extending sides past the vertices. So same old story. All right, and then I'll give you the measures for these folks. I'll start down here in the bottom left corner. So 43, 74, 11x, 12x, 37, 17x, 50, and 12x. Okay? Again, the idea is pretty easy. It's just add up all the exterior angles. I'm going to choose to start with this one. And the sum will be 360. So I'm going to start at this 43 and just work myself around. So the first one's 43, then 74, then 11x, then 12x, then 37, then 17x, then 50, then 12x. That gets me back to where I started. So the sum of all those will be 360. All right, so 43 plus 74 plus 11x plus 12x plus 37 plus 17x plus 50 plus 12x equals 360. Like usual, we'll put all the terms with x's together. So 11x's plus 12x's plus 17x's plus 12x's. Let's see, that's going to be 23, 33, 40, 52 x's. So that'll be 52 x's. Then we add together all of the plain old angles. So the 43, the 74, the 37, and the 50. So we just add those folks together. 43, 74, 37, and 50. And we get a total of 204. I just need a little extra room, so I'll shrink this slightly. I'll move plus 204 to the other side by subtraction. So we get 156, and then divide both sides by 52. So the value for x, then I'll put it up in our usual position here. The value for x then is going to be 156 divided by 52, which is 3. Okay? All right. So there's quite a few examples, 4 examples of working with the polygon exterior angles theorem. All right? The sum of the exterior angles always 360. Okay, and now we'll change gears a little bit and just finish off with one last type of problem. No theorem, no formula or anything like that. You just need to think these through a little bit. And they're going to end up being pretty simple. Okay, so one last problem. And I'll give you a couple of examples, but I'll just write out the directions once. The directions are going to be this. Find both the interior angle and the exterior angle given the regular polygon. All right, and so in our first example, the type of polygon I'm going to give you is a octagon. All right, octagon, if you don't remember the prefix, means 8 sides. All right, and so what I'm going to ask you to do is find both the interior angle and exterior angle given the regular polygon. Now what I really need you to remember is what the word regular means in terms of polygons. And what it means is that we have a polygon where all of the sides are equal and all of the angles are equal. So regular means both equal sides and equal angles. Or I could have used the fancier words equilateral and equiangular. All right, everything's equal. Everything is equal. Now what this does for us is it allows us to find all of the interior angles because they're all the same. And because all of the interior angles are equal, all of the exterior angles are equal. And so I just want to show you how that's going to work. It's easier than it sounds. So I'll show you how to find an interior, and I'll show you how to find the exterior. Okay, one's a little easier than the other, although neither of them are too difficult. Okay, the theorem we just got through talking about today says that the sum of the exterior angles is always 360. So to find the measure of one of the exterior angles, we just simply have to take 360 degrees and divide by how many exterior angles there would be, which is going to be the same as the number of sides. So what we end up with then, guys, is 360 divided by 8. And that means that every exterior angle would be 45 degrees. Now the interior is a little bit tougher because what you have to do is you have to find the sum of the interior angles. And I'm just going to make that plural. So sum of the interiors. Then divide the sum of the interiors by the number of interior angles, which would be 8. Now remember to find the sum of the interior angles. Now I have to have you go back, think back, remember back to when we started chapter 8 before the long weekend, before President's Weekend. I showed you that you could find the sum of the interior angles by taking 180 degrees times the number of sides minus 2. 180 degrees times the number of sides minus 2. So since we're talking about an octagon, the number of sides is going to be 8. And so the math then turns into 180 times 6 divided by 8. 8 minus 2 is 6. So the sum of the interior angles would be 180 times 6, so 1,080. But then we have to divide by 8, and so we get an interior angle being 135. Now what I'd like you to notice, we have our two answers. We could circle or box those up and be done. We have the interiors. Every one of the 8 interiors would be 135. Every one of the 8 exteriors would be 45. But I just need you to notice one thing that'll make this even easier as you move forward. Please notice that one of the interiors plus one of the exteriors is 180 degrees, which I hope makes sense if you remember the way we defined exterior angles way back in whatever that was, chapter 2 or 3. I hope it makes sense that those two add up to 180 or are supplementary. Okay? So just bop through a couple more examples so everybody could have a couple in their notebook if you'd like. What if we were to do the same thing with a decagon? Well, first of all, you'd have to remember the definition for a decagon means a polygon with 10 sides. So can you find every one of the interior angles of a regular decagon? And can you find each of the exterior angles of a regular decagon? Again, exterior is easy because the exteriors always add up to 360. So we just simply take 360 and divide by the number of exterior angles, which is the same as the number of sides. And so therefore an exterior angle is going to be 36. The interior is a little bit tougher because we have to find the sum of all of the interior angles, which is 180 times the number of sides minus 2. And then we have to divide by how many interior angles there are. So the math turns into 10 minus 2, 8. 180 times 8, which is 1,440. And then divided by 10 gives us 144. So every interior angle, 144. Every exterior angle, 36. And as just kind of a check, add those two together, we get 180. Okay, and one last example and then we'll call it a day. One last. What if instead of 8 sides or 10 sides, what if we had a 50gon? Right? What if we gave you a regular 50gon, meaning a 50-sided polygon, all the sides are equal, all the angles are equal. Could you find the measure of an interior? And could you find a measure of the exterior? Regular, remember all sides are equal, all angles are equal, polygon. Okay, again, exterior, easy McPeasy, because it's just the total of all the exteriors divided by how many angles there would be. So 360 divided by 50 would get us an exterior angle being 7.2. An interior angle requires us to find the sum of all 50 interior angles, and we do that by taking 180 times the number of sides minus 2, divided by then, that'll give us the sum of all the interiors, but then divided by how many there are. And so the math turns into 50 minus 2, 180 times 48, so 8,640. And then divide by 50, and we get 172.8. And again, just as a check, when you're doing these on your own, those two angles should always be supplementary. Those two angles should always be supplementary. Okay? So that's going to be it for section 1. That'll be it for section 1. All right, so that assignment, you guys should be able to button up now, I hope. And you should be able to then get that to me, you should be able to get that to me tomorrow. Okay, send it electronically. Get that one to me by tomorrow. Okay? Alrighty, so have a great day. Finish up this assignment, get this one done. Get it ready to turn in tomorrow, and then we'll get ourselves started on section 2 tomorrow. Okay, hope you're having a good day, and we'll talk to you guys soon. See ya.